before I start, I just wanted to know what you are and then what are you looking for. Just a moment.
Hello.
Hello.
So please tell me what you are and then what level of code you are expecting. Hello.
Hello. Yeah, I'm from mechanical background.
Okay.
Yeah.
Yes.
So I'm
Yes.
interested in yeah.
That's
Hello.
fine. That's fine. What about the rest? The others. Fine. Yeah. Yeah.
Hi sir, my name is Teja and I'm from electronics background.
I think you're fine. That's fantastic. Yeah. Fine. Are you able to see my screen?
Yeah.
Yeah. Fine.
Yes.
Okay.
Yes.
Hope the others are also in the demo and active. Let's begin. So you guys are from different backgrounds, that's fine, not an issue. So let's try to understand what's an infrastructure is and how a cloud technology is important, what way it is useful, how it is advantage uh, to learn and all. So to begin with, I just wanted to say, since it is cloud technology, I just wanted to, let you guys know what's cloud computing. And to understand that, first let us understand what is infrastructure, how an organization's infrastructure is built. So let's understand this way. Okay, anything we needed a developer, first thing. So for example, if there is a client A, okay, a client is existing and the client comes to a company, ask for an application to be developed for his purpose or his organization purpose, for anything it is, or maybe for his business. So when a project is given by a client to develop an application or anything, so we hire a developer. The developer is hired to develop that, and what he does is he just write a code, or he try to, basic thing is we write a code and then based on that an application is developed. But when a developer wanted to write a code or develop the application based on the client's requirement, okay, he must require a computer. The basic thing is he must require a computer. Alright, and not only a computer with a OS in that. The basic thing is a computer with OS and all the supporting applications for his development to be there in that computer. Okay, the computer is nothing but, in our language we say it's a server. So the developer wants a server, and is that enough? Is provided with a server with all the supporting software installed in it. It's not only that, because when a developer is working on something towards the client's project or client's application, he must need a proper security for that, because it is a part of organization. The developer is working for an organization, for a company. So the company's data is very critical, very crucial, so that nobody else can access to that. So there should be a proper security around that server. And when we are working on a project, we always keep the data very safe. So for that, there are multiple options we take. We sometimes keep the data in our local machine, or we sometimes go with another storage, so that we keep that data safely in that other storage. So sometimes we also take storage, additional storage. For that, we need storage guide. So what I'm trying to tell you is, when a developer wants to work behind the screen, there are so many people support these developer, okay, with a proper server, with a proper access to that server, and then the server should be healthy, up and running all the time. And to happen that, you see how many people work behind. Like, a developer is one side and an admin guy in other side, and there are a number of admin people who works for this system up and running. So anything, whenever I say a system or a machine or a server or a computer, that all that means the same. Okay, so what and all, how many admin guys work? See, first, hardware engineer will be there, if all the to check whether all the hardware parts, or whether that server hardware is properly fit and working fine, the condition is fine. Then the basic OS, so OS guy will be hired to check whether OS is working fine, properly working, and the system is booting properly. After that, application engineer will be there, so that to check all the applications are working fine or not, so that the developer can work properly without any disturbance. After that, if we have any additional storage, so that storage engineer will work to check whether the storage is working fine or not, it can be accessed properly or not, whether all the data can be properly saved in it or not. If the data is very crucial, and if you wanted an additional copy of that, so backup engineer will be there to take the backup of that entire data. And to access this, because the client will be in one location, and then the developer is another location, so all the time the client wanted to check his project, how it is getting progressed. In order to do that, we probably keep our server in client's location, so that he can access whenever he wanted, and we work by being in some other location. So there needs to be an access. Okay, whenever we wanted, we should be able to access. So there should be a proper network, so that network engineer will work. As I said, it need to be secured properly, so a security engineer will work. Like this, there are so many people work behind the screen for a proper development. Okay, in order to work a developer without having any issues, so many admins work behind the screen to have or to provide a healthy server. Now, okay, let's understand an infrastructure. Now we just understood what is, usually happens in an organization when a project when a project comes to us. Now, when we are trying to understand infrastructure, let's understand this way. So every infrastructure will have a data center. Now, what do you mean by data center? Data center is nothing but it's a combination of, what and all we have listed so far. Servers, number of servers we require towards our infrastructure, so much of storage, database, proper network, and security. All these cumulatively known as data center. So a proper data center should be built for our proper production or proper development. Only with that data center we'll be able to work. So I just listed what's meant by data center. Data center is nothing but the combination of server, storage, and all. Whatever we require for our infrastructure, or for our organization, or for our development towards the projects we have. Hope that makes sense for you. Now let's understand. If it is a physical data center, we have to purchase all the hardware towards our servers, databases, and all. Even storage, we need to purchase everything from another guy, from a different vendor, because servers are provided by somebody, storage is provided by somebody. So like that, we have to go and meet so many different vendors who provide what we require. So get the quotation. After once we get the quotation, the quotation needs to be approved by our organization. Then we place the order. That order needs to be approved. Okay. After once the order is approved, they should send the hardware or all the machinery parts to our location. Once everything comes to our location, it needs to be fixed properly. Okay. After once it is fixed, there should be all the supporting softwares, including OS, needs to be installed in it. After that is done, we test whether the data center is working fine or not. Once we conclude everything is working fine, then we make it alive for our live production. Till then, it probably take 2 to 3 weeks of time. Alright, and we are spending lakhs of rupees here in this case if it is Indian currency. Lakhs of rupees, and 2 to 3 weeks of time it probably takes to build a data center and to start work on it for our projects. But when it comes to cloud, okay, this is where cloud has become popular. The cloud computing has come into the picture because of reducing the time constraint, so that we can develop our data centers, so that we can just build our data centers in a matter of less time, very as less as possible of time. Then not only time constraint, but it is also in terms of revenue. So the amount we pay, we are spending in a physical data center. To build a physical data center, we are spending lakhs of rupees. But if you just go and build the data center in the cloud, it will probably take only the thousands of rupees. I'll tell you in another way. Okay, you are having a project now currently and started working. You have a physical data center, fine. You, okay, whatever it is, you spend lakhs of rupees, however it is, you spend everything, and then you make everything ready for yourself. You started working on the project, and then the project is completed, done. You're done with the project. You have also delivered that project to the client, and the client is happy, fine. What happens once you're done with your project and now you are ideal without having any projects? What about your data center that's not being used? And the amount whatever you spend, your entire investment is just being idle without being utilized. So it's a waste of our investment. Of course, if you have so much of revenue generated towards your project which is just completed, then it's fine. But whatever it is, though you have profit, that entire data center is not being used. You have you have so much of space consumed by the data center. You have an organization set up, and you again have to work on getting another project. Still you get the project, you will be just simply being idle. But if you come to cloud, okay, you purchased an infrastructure, which means you have developed an infrastructure, you built your infrastructure in the cloud, and you're done with your project. You can just simply say to the cloud provider saying we are done with our project, our work, so that that infrastructure will be terminated, will be taken back, which is nothing but terminated. In this case, why this is done? Because whenever you want, this is just a cloud, whenever you want, you can just build your data center on your requirement, as per your requirement, towards your project. That you have so much of freedom. It's totally up to you. And once you're done with your project, you can just say you're done, so that the entire infrastructure will be terminated. This is because you are charged for the resources utilized, okay, for the resources utilized, and for the amount of time you utilize. So it's just like you are charged, like how you have your postpaid connection. So you speak and whatever the amount of time you speak, you are charged. That's all. Now, these are the advantages we have with the cloud computing. So let's try to understand what's cloud computing. To begin to understand with that, I just like to explain. So if you wanted to understand cloud computing, there are so many n number of definitions available, and so many people have defined in their own way. So now let me define what I understood in terms of 5 attributes. Okay. So with these 5 attributes, let's try to understand what cloud computing is. Now, first thing in that is, okay, broad network access. So why do we need to have an access? First thing, it's a cloud, okay, and in the cloud, any number of people can access and can build their data centers into it. Okay, before I just go with this, I just like to tell you there are two different type of clouds we have, public and private cloud. I'll just differentiate between these two little later once we understand what cloud computing is. Okay, so now AWS, when it comes to AWS is a public cloud. Since it is a public cloud, any number of people can access, everybody can access. Public means it's open to everybody so that anybody can access and build their data centers into it, so that it requires a broad network access so that anybody can access from any corner of the world. That's the first point. And the second point is on demand. So what do you mean by on demand? On demand is nothing but we don't need to request and wait for something here in cloud. We always have to demand that what we require, and that's been provided by us. If you wanted a server, you just demand for them for the server, any number of servers you wanted, then you are allowed to build based on your requirement. Anything, it's not only about a server, it's anything you wanted, any service you wanted to utilize, you can just utilize without having any issue. So that's what on-demand self-service. The next comes pay as you go. This is very important. Pay as you go. So what do you mean by pay as you go? You are charged here in this cloud computing. You are charged only for the resources utilized and for the amount of time you utilize it. This is how you are able to save so much of your amount, your revenue. Okay, and I would like to explain this in another way. Like you are a developer, for example, you are a developer, you have a code to be executed and to check its output, or you are a testing guy, you have an application to be tested. So for that, also, you require a setup. Setup is nothing but a data center or a server with all the supporting software installed into it. But how long do you require that server? Maybe a couple of hours or maybe a session from morning to evening. Alright, because you wanted to test something and that doesn't take so much of time. Okay, even if it takes one day, what happens after one day? Alright, so that entire setup is waste after once you are done with your work. But if for that, if you wanted a physical server, you need to spend so much of money, and once you're done with your work, that server is being waste. If it is cloud, you ask or you demand for whatever you require, whether it is a server or anything, any service, you demand, you get that, you do your work, and once you're done with your work, you say you're finished, you're okay with that. So that the resources are taken back and you're charged only for the amount of time you utilized, so that you can save your money, okay, and you can also finish your work without having any issues smoothly. So that's what pay as you go. You pay only for the amount of resources, for the resources utilized, for the amount of time you use. The next comes rapid elasticity. What's meant by rapid elasticity? I wanted to explain this a little clearly. A rapid elasticity. For example, okay, I just wanted to explain this way. So, for example, we have a website. Okay, we have an organization, we have a company, and for our company, we have a website. That website maybe belongs to something like we are trying to do some business, and that's online, so anybody can access our website and purchase whatever they wanted from what we are selling. It's just like that, you understand, try to understand. It's an example I wanted to give. So when you are trying to, sell something, the website where people are trying to access. Okay, for example, you have some 2000 requests hitting to our website every day, for example, and occasionally we have announced a special discount sale. So obviously, when we announce a special discount sale, the number of people access our website obviously increase. Alright, so when number of people accessing our website starts increasing, and on that particular special occasion, when the number of people accessing our website increases, do we have any proper expectation? Can we expect how many people go access our website? Normally, on an everyday, we are experiencing 2000 hits to our website. On this occasion, can we expect how, up to what limit it extends? Alright, if we have an expectation, we can define or we can just frame our infrastructure towards that. For example, if we expect 6000 requests hit your application or your website, and initially when 2000 requests are hitting to your website, one server is being enough to reach or to meet up all that requirements. And when you expect 6000 requests to your website, then probably you may need 3 servers. But can you exactly say you will have 6000 users or 6000 requests come to your application? No, we cannot expect anything, right? So without having any expectation, without knowing anything about what will be the queue size, what will be the request hitting to a website, how can we frame our infrastructure? Okay, fine, we roughly estimated, for example, what I said 6000, we roughly estimated, and we have 3 servers dedicatedly assigned for our infrastructure, our website. What happens if our expectation go wrong in either ways, like if it goes more than more than our expectation, or if it goes lesser than our expectation? We'll try to understand in both the ways. Like if it goes beyond our expectation, instead of 6000, if 10,000 requests come to our website, are we able to meet up the requirement with the limited servers? With the 3 servers we have, no, not possible, right? And our servers will experience a huge load, and if they experience huge load, they may even go crash. So we are not meeting the requirement, we are not serving the people, then we have failed. End of the day, we have failed to serve people. Or else, in other way, if we get less amount of requests, for example, instead of 6000, if we get only 4000 requests, so for that 4000, only 2 servers are enough. What about the other third server? It's not being used. It's waste. We did not use that. But still, we are paying for that, the third server which we have taken. So this way, either we are paying additionally without using the resources, or we are not meeting up the requirement when people are hitting our website. So to overcome this, we go beyond, we just depend upon, or we just take the help of this rapid elasticity. It's just like a rubber band where you stretch, it will get stretched, you leave it, it will get contracted. So same thing, we have a mechanism in cloud. Okay, if it is physical thing, you wanted to, for example, the load is increasing from 6000, it's going above, and then the load is increasing, and you wanted to build physical servers. It's not possible, because to build a physical server you need to install everything physically and then you test. By then your sale will be end. It's not possible in physical thing, but in cloud we have a mechanism saying scaling up, scaling down, auto scaling we say. So that auto scaling is used here, and based on our load hitting to our website, okay, load hitting to website, the auto scaling spin up the instances. Now don't get confused. Instance is nothing but a server. That is nothing but instance is a server in terms of our AWS. So we say a server, we refer a server as an instance in our AWS cloud. So this auto scaling spin up instances based on the load hitting our website. So we currently have 2000 users hitting our website, so we have only one server, and expecting 6000 you use, okay, 3000, sorry, three servers. When it just goes beyond that, automatically this auto scaling spin up the instances or servers, so that you can meet up all the requirement, and then you serve all the clients, or sorry, all the people who request or who access your website. Then once the sale is done, or once the load is reducing, auto scaling is also smart enough to terminate the instances which are being idle, so that you pay very less, or you pay only the resources you are utilizing. So that is what rapid elasticity. Okay, rapid elasticity is nothing but it will scale up or scale down your infrastructure based on the access, or based on the utilization, or based on the request hitting to your application or website. So that is possible in cloud. That's fantastic, right? So that is a really good idea, a really good mechanism where cloud people or cloud technology has come up with. The next thing is research pooling. Now, what do you mean by research pooling? Now, of course, as I said, we have a website wherein 2000 requests are coming and hitting to our website every day. Okay. Now, in a couple of months, our website has become popular. Then the queue size, or the request size, has increased from 2000 to 4000, for example. So we develop our infrastructure. We expand our infrastructure from one server to two server, and in another couple of months, it has become even more popular. Maybe, for example, we say 6000. So what do we do now? Keeping our future in our mind. Okay, our site is turning popular day by day. So now this time, rather we go and extend our infrastructure by one more server, thinking about future. What I'm doing is I'm going to have five servers, like thinking that my site become popular, our website become popular, and then we may have 10,000 requests in the future. So I have expanded our infrastructure for five servers, for example. Okay, now let's understand this way. Of course, our website has become popular, but not to our expectations. Like, we have expected for 10,000 requests per day. It has gone to only 8,000 requests per day. So in this case, we are, able to serve these 8,000 requests with four servers only. But how many servers we have now currently serving for our organization? Five servers. So there is a server which is being idle in this case. So what do? We cannot terminate that server, because the future we may get a more request, and we are not keeping that. I mean, like, we may not keep that unnecessarily and pay, because that is an additional burden for us, right? So what do in this case? We have an option in our cloud that all the additional resources which are being idle for our organization, in our organization, can be kept in the marketplace. We have a marketplace here in our cloud, especially in AWS. So all these resources, once placed in marketplace, somebody else will utilize these additional resources, and they pay on behalf of us. So that's what resource pooling. Alright, so these are the five attributes. Any cloud computing which meets, or anything which meet up all these five cloud attributes, then that is said to be a proper cloud computing cloud provider. Now, let's understand. So AWS is very much suitable with all this, very much satisfied with all these 5 attributes. Okay, now let's understand. As I said, there are 2 different type of clouds, public cloud and private cloud, and AWS is a public cloud. So let's understand what is the difference between public cloud and private cloud. You see, when it comes to public, it is open to everybody so that anybody can access and anybody can build their data centers or their infrastructures into it. So that flexible it is. And of course, it is, AWS is satisfying all these 5 attributes, so it's quite comfortable for anybody to opt for this and then build their data centers in it. And if it is a public, this is how it works. And if it is a private, okay, a private cloud is dedicated to only one organization, and that is why people go for a private cloud is the only reason, because of security. When it is a public cloud, anybody can access that and can build their infrastructures into it. So what happens? Of course, this won't happen because so many people are opting for AWS and then they already have their infrastructures into AWS. But there are people who are very much worried about the security. What if somebody gets the access to our infrastructure since it is a public cloud? I wanted to build my infrastructure in the cloud, but I wanted it to be only for my organization. So for such kind of people, private cloud is defined. But the challenge is, okay, a public cloud, in the public cloud, you need not to worry about your data center because it will not be there physically with you. So you are not going to maintain any data center. If something goes wrong, if some issue comes up, you just notify to the cloud provider. For example, here in this case, AWS people, so they will just come up with with a fix or with a solution and suggest us to fix that in a proper way. They'll help us, so we are fine, we'll be able to do that. But if it is a private cloud, you should have, or the organization should have, entire data center again. Okay, so we should maintain it, and if anything goes wrong, any problem arise, then we ourselves should jump into it and then dig down where the issue is. If it is in the cloud, we should fix it there. If it is in the data center, then we should go fix that from the root cause. So everything is challenging in a private cloud. And in other way, if some disaster happens where your data center is located in a private cloud, then your entire setup is gone. Everything is gone. You have to build everything newly. But what if something happens when it is in a public cloud? Not an issue. People will tell you to, you are flexible to build your infrastructure very freshly in a matter of no time. And of course, you can build your own infrastructure which was existing already. And then now, because of the data we have in multiple locations. All right, the multiple regions, we said regions. I'll just clear that what you mean by regions and all in a moment. So these are the differences between private and public cloud. Both of them have got challenges, like when you wanted high security, not a problem, that you can maintain your data center and you just, hello, Teja, you saying something?
Hello?
Yeah, you texted me something?
No, no, sir.
Yeah, fine,
No,
fine.
no, no, sir. Nothing else.
So if people are worried about the security and they are fine for the data center, the physical data center that they can maintain securely, properly, then they go with the cloud, private cloud. But for a person who are worried about budget and who don't want to take any risk maintaining the data center and all, then public cloud is pretty much suitable for them. So that is a reason why public people are opting for a public cloud, saying need not to maintain any data center, so we did not to worry anything about. And the payments, the budget, because private cloud you need to have a data center, so you again have to spend lakhs of rupees again. But here in this case, you don't need to spend anything in that way. Everything you just go create an account. Only account, one account is needed to create or to utilize public cloud. So this is my account. Okay, when it comes to AWS, this is my account. I have logged into it. Anything for an organization, you just require one account to be created. Once you create an account, you are allowed to do anything in that. You are allowed to utilize any service it is. You are allowed to create any number of infrastructures into it based on your number of projects. So that is how it's flexible. And how much you're paying in the end? You're paying only for the resources utilized and for the amount of time you utilize it. Hope I'm making sense for you guys. Everything is clear. You're getting everything. Anything, any doubt arises into your mind, you just get it clarified on the spot. I'm okay with that. Now, we have seen what's cloud computing. We have also seen what's the, the different type of clouds, private cloud and public cloud, and then the differences between them and their challenges, their advantages. And initially, we have seen how this cloud computing is advantage than a normal, physical data center or physical hardware or physical infrastructure. Then let's go see the different models, deployment models of cloud. So the different deployment models of cloud are, these are important things you have to understand. SaaS, which is nothing but software as a service, and this is for an end user. I'll clearly elaborate it. What this is? This is for an end user. So when since there are so many cloud providers, okay, though it is a public or private, when it comes to public cloud, Amazon has come up with AWS, Amazon Web Services. Then we have Microsoft people's Azure, and Google has their own product, Google Cloud. IBM has their own cloud, soft layer. So like that, there are so many cloud providers in the market. But among all, Amazon has its first position, and it's just because their low prices and high flexibility, high infrastructure. I'll just explain in another moment. So the deployment models are, since there are many cloud providers, they just wanted to get the revenue towards their business. They have different models. So there are three different models we have to understand. That's first one is SaaS, software as a service, and that's useful for a particular end user. So which is nothing but they provide any software you wanted in the cloud. There are so many softwares built in, and those softwares individually, you already have an infrastructure ready-made and set up, okay, a proper setup for you, but you wanted a particular software to be utilized. So these people provide you that software, and you can utilize it without any issues. For example, I would like to give, Microsoft has come up with Office 365. I don't know whether you have heard about it or not. So Office 365 is a mailing service to communicate in between inside our organization with our client and internally. So normally, people use Outlook, Microsoft's Outlook, for their communication purpose. But when you use Outlook, you need to have all the mailing server. So when you're communicating with the people, you need to have a server separately dedicated for that we say mailing server or exchange server. So if something goes wrong, you just can retrieve all the mails. So which day, what mails you sent to whom and all. But when you go with O365 or Office 365, what people say is you use this software with n number of licenses, and you don't need to worry anything about exchange box. We maintain it on behalf of you, and if something goes wrong, we will get you the data. So that's quite comfortable, right? Who's going to have a headache of maintaining Exchange box, and for that you need to have another team, Exchange team. So when you use this Office 365, nothing to worry. They'll maintain everything for you, and then you just utilize, and also providing you a number of licenses with the application, with the software. So that's how, and you pay some amount for that. That's really comfortable, right? So that's what software as a service. You just wanted, you have established infrastructure, and you wanted one particular software. Go purchase that, or go take that, and you pay how much you are utilizing that. So this is why it is mentioned the software as a service is specially for an end user. The next thing is platform as a service, PaaS, platform as a service, patch fixing. The platform as a service is for a developer. Now you are a developer and need to test something. When you wanted to test something, it's not that you require one particular software, but it is that you wanted a server with all the ready-made softwares readily built in it. So you wanted a platform for you, so that you can test your application, or you can test you can execute your code and then check whether everything is working fine or not. So that is what platform as a service. We also have that service. I mean, we also have in it in our AWS. We can just expect a platform when you are a developer, and then do your work, and then done. You can finish your work and then say, yes, I'm done with. Then next, this is where we focus more throughout our course. Our course is defined in this layer. Of course, and all the three layers are covered, but this is where we focus more. That's last one, IaaS, infrastructure as a service. This is for an organization. Okay. So what do you mean by infrastructure as a service? Infrastructure as a service is nothing but whenever you are trying to build your infrastructure in the cloud, we should be able to do that. We should be able to provide a service to a flexibility to build entire infrastructure in the cloud for an organization. When an organization comes to you and ask for an infrastructure built towards their applications or their projects, so you take their inputs and then define an infrastructure based on their requirement and then provide them. That's all. So this is what infrastructure as a service. And to build an infrastructure, we need to understand so many things in the cloud, in especially in our AWS, because this is AWS demo. So let's see what and all we need to understand, we need to know in AWS. So this is all about cloud computing and how advantage, how useful the cloud is. Now we'll focus what we will understand, what we will cover throughout our course. Okay, in AWS especially. So this is just like a curriculum or a course content, what and all the topics we cover. To build an infrastructure, as I said, infrastructure is nothing but a data center, and data center is nothing but the combination of servers, storage, database, network, security, and all. So all those things are here. You can just build everything in that. So first thing, when it comes to compute, we will discuss a lot about EC2. So EC2 is nothing but what a little description given underneath of that. That is just a virtual server in the cloud. So whenever you wanted to build a server in the cloud, this is where we go. We go to EC2 and then we build EC2 instances. Instance is nothing but a server, as I said. Okay. So any number of servers, and it's not like physical. You wanted a server, you can just build a server in a matter of minutes, just a minute, just in a minute or less than a minute. You can create a server with all the required software installed in it. So you see how quick it is and how comfortable it is. You don't need to waste so much of time. You don't need to go for a quotation, place the order and all and all. That's really a lot more time consuming. But here, in a matter of minute or less than a minute, you can just create a server. That is where it's really flexible. So not only creating a server, we speak a lot in this EC2, like about volumes and additional volume, because you have the computer will have a dedicated hard disk to that. That hard disk will have certain memory. When you wanted to extend that, it's like an additional hard disk or an additional volume we wanted. So we speak about some volumes. That's nothing but an additional storage in that. We'll detailedly understand during our course what it is. And not only that, when we create a server, how do we safeguard it? How do we secure it? Okay, so we will also see about a server's security, and not only that, we also discuss something about load balancer, auto scaling, and all. There is so much of stuff we need to understand, so that I can say EC2 is the heart of our entire course. Once we understand EC2 clearly, I can say the 40% of our course is done. So that huge it is, that important it is. Then after once this is done, we will discuss this EC2 lot more practically. Okay, we'll become hands-on on that. Then we speak something very little about Lambda, that's theoretically, and with the little description we can understand that it is just a platform. You have a code to be executed, so you wanted a platform, then you run a code in response to events. So the events are created, which is nothing but a platform is provided to you. You use that, okay, you execute your things, and then fine, you are done with your work. So we speak something about Lambda theoretically but not practically. Then we are done with compute. Then comes to storage content delivery. Under this we speak about S3. It is a scalable storage. It is just like, if you wanted to compare, it is just like Google Drive. Hope you have used Google Drive. To save our documents and files, we use Google Drive, we keep in that, and then we access wherever we want. We are over network, internet. So you have internet, you keep your files, you upload your files into Google Drive, and then you access from anywhere in the internet. So the same kind of thing is this. So storage, it's a storage, scalable storage in the cloud. It's not only scalable, it is a massive storage, unlimited storage provided for you in this S3. So we create containers, nothing but buckets we say in our AWS language. So bucket is nothing but a container wherein you can just keep your files or upload your files into that. So we see this practically. Cloudfront is another thing, that is global content delivery network, CDN centers we say, and each CDN center we built Cloudfront distributions. So this is done, this is used for, okay, latency, to reduce latency. Your website is built in some location, and that needs to be accessed by some other location people. So in order to reduce that latency, we create Cloudfront distributions, so that they'll have the cache of that website or anything the other people are trying to access in their local regions. So whenever they access for the next time, they rather go to that original location, the request will be sent to that CDN centers, the distributions which are created, which have the cache of that, and from that cache, within no time, you will get all the data or all the things whichever you are trying to access, the people are trying to access. So this is where it is used to reduce the latency. So we see this also practically, how do we create the distributions and all, how it works. So these two things we see very much, pretty much practically. And we discussed something about elastic file system, though it is under previous state. We discussed something theoretically under EC2 level only, not an issue. And we speak something about Glacier. We see something how to do, how to use this service, while we talk about S3 only. So Glacier is nothing but what? It is just archive storage in the cloud. So to understand this archive, you need to know about backup. So what do you mean by backup? Backup is nothing but what? You have a copy into your local machine, and when you're trying to, backup, you'll have an additional copy into another remote location. So when something happens, something goes wrong with your current data in your local machine, so that you just retrieve it back, you just recover it back from the additional copy we have in other remote location. Okay, what happens if your local machine is total, I mean, the total space is full, totally occupied. you have some space crunch. So you wanted to clear that space, right? So in that situation, what do? You cannot simply delete your files because those files may be reused or used by you again in the future. So such kind of data, what do? You remove from your local machine, but you'll have an additional copy somewhere. So backup is just like copy paste, whereas archiving is nothing but cut paste. You'll not have an additional copy into your local machine, but you'll have a one and only one copy into another remote location. In the future, you wanted, you'll be able to retrieve it back. So such kind of thing is archiving. Archiving is nothing but just like cut and paste. You'll have the data, but not in your local machine, somewhere else. So how do we move data into Glacier? We will see that, we will discuss that while we speak about S3 only. Then after that we see something theoretically a little about Snowball and the storage gateway. This is all about storage. So we are done with storage. After once that's done, we come down to database. So database, under this we see about two different databases. One is relational database, that is RDS. So okay, so relational database, it's nothing but MySQL, PostgreSQL, Aurora, etc., etc. Then we see something non-relational database, that is NoSQL, DynamoDB. So these two things we see practically, how do we create databases, how to use that and all. Then we speak something theoretically about Elastic Cache and Redshift. You able to hear me? Hope all are able to hear me and make some sense. There is an issue. Looks like there is an issue with my mic, my connection. Hello?
Hello.
Yeah, can you hear me? One moment, looks like there is a problem. Yeah, I think. Are you able to hear me? Just a second. I think there is an issue with my network.
Hello?
Hello.
Hello?
Uh,
You able to hear me?
Yes.
Yes.
Oh, fine. There was a little disturbance with the network. I'm sorry for that. Fine. So what I'm trying to tell you is about database, right?
Yes.
So we'll see how to create relational databases and non-relational databases, and then we speak something about Elastic Cache and Redshift theoretically. And next, okay, we come to networking. So this is where people says it's a public cloud. How do we depend on a public cloud? How secure it is once we create our infrastructures into it? So nothing to worry. We have an option of isolating our resources in this public cloud, though it's open to everybody. That's possible by this VPC under networking. So it's, what is the description? Isolated cloud resources. So VPC is nothing but virtual private cloud. So we can isolate our entire organization with a dedicated network with this VPC, so that nobody else can access to us to that. Then we speak about Route 53. Route 53 is nothing but what? Domain naming. Once you create your organization, by default, you are provided with a domain name. And that domain name is not user friendly. Like, you may have a combination of numbers, IP addresses and all and all. For example, you have a website, maybe for example, Amazon.com. Initially when we create a website or an application, that will be provided with a default domain name that's not user friendly, where people may not be able to remember that. So how do we able to make them remember? We need to have an easy name wherein they can remember, and once they type this, that should uh, uh, re, uh, uh, redirected to our website. So that's how we just give a name, we register a name, then that name is to be allocated to our website, just like Amazon.com, Flipkart.com, Yahoo.com, Google.com, Gmail.com, just something like that. So all these are domain names which are already registered and associated with our with their websites, so that people can easily remember. And in the behind the screen, any number of times they change, they modify, their IP addresses changed or their domain name changed, then they associate with this name, so that people will not have any issue accessing that. So that is what this Route 53 is, domain naming service. DNS is nothing but domain naming service, and we also have to register that. The registration of domain names is must. So we see that Route 53, how to associate a domain name with the infrastructure creator or with the default domain name. So let's understand this way. Uh, hello, hello. You able to hear me? Uh, just a second. Hello. Yeah, I'm sorry again for the disturbance. Hope you're hearing. Uh,
Yeah.
so that's what. So why do we name? Why is it named as Route 53? It's just because the DNS works on port number 53, so that it is named as Route 53. Okay, understood. The next we speak about identity and access management. Okay, now you have an account created in AWS. Okay, and you have a number of cloud resources, cloud engineers working towards your organization to build number of infrastructures into it. But how do you allow them to access that one particular root account? Will you provide that root account details to everybody, all of your cloud engineers? That's not possible, right? So initially root will be only one, the owner will be only one, and in that we should provide access to them by creating them as a user. Okay, so how do we do that? We do that by creating them as a users into our account, and we set the level of access to them based on their role and responsibilities in the organization. So that's possible here under this security and identity, under this identity and access management. So we say simply IAM, identity and access management. It is all about manage user access. So we create all of the users into this, and we set their level of access based on their roles. So that is that we see practically. And then we see something about Cloudwatch. Cloudwatch is nothing but it is a monitoring service. We discuss Cloudwatch under EC2 level. Okay, so how healthy our environment is once created, how healthy our servers are, what's their CPU utilization, what's their input output throughputs. So all those things will be monitored here, and we create some alarms if something is going wrong, so that we can those based on those alarms we get notified what's happening, and then we can just jump into that and then fix whatever it is, whatever the issue is. So that's all about CloudWatch, the monitoring stuff. And then we speak something about simple notification service. We see something practical impact. So notification service is what it push notifications, like you have a data center built. Okay, and now you are not currently not in the office, but something is happening in your data center or something going wrong. How do you get to know that? By the time you get to know, by the time you go back to your office and check, by then something goes wrong and something nasty happens, and then you have to fix everything from the scratch. Rather than that, if you get notified maybe in terms of an email or a text message onto your mobile, That will be comfortable. That will be very nice, right? So that the moment the issue starts, at the moment you know something is happening, you will log in and then fix it, or you will just take it. It will not happen in another way, or go beyond, you know, or go damage more than what it is. So that is what the notification services are useful. It pushes the notifications. Understand push, because there is something else pulling. So next comes to SES. It's nothing but simple email service. I said you have a website and you are announcing some special occasions or special day sales. So how do you notify your people? So you send bulk amount of emails to all the people who are accessing your website, or you're trying to accessing, or accessed earlier in the in the past. So to all of them you send bulk amount of emails and notify them that so and so day you are going to conduct a big day sale. That's what happens, right? In Amazon or Flipkart, we just get notifications in terms of emails. So we'll get to know what's happening or what sales are going to be, and what days they are going to conduct. And also, this is what emailing service, simple email service. Then we talk about simple queue service. So I can say this is pretty much important in terms of examination point of view or certification point of view, because Amazon has started their cloud services in the year 2006, initially with simple queue service, SQS only. That is the reason why maybe you can understand that in terms of a sentiment that they have started their cloud services initially with simple queue service, so that it is important in terms of certification point of view. So simple queue service is nothing but, you see, you have a web server, web application where a number of people are accessing that. So how do you notice, how do you, and come to know that whether all the people are try to access your web server, sorry, web application website, all the peoples are served properly. So this simple queue service is helpful. Whenever a request come to a website, that will be queued, okay, and it makes sure, the simple queue service makes sure it addressed at least for one time, so that you can just save, take care of your request hitting to your website. Alright, so that's what a simple queue service is. And then we speak something about simple workflow service, the SWF. So whenever you purchase something online using e-commerce sites, there will be a workflow created soon after your payment is successfully done. So how a workflow is done, the workflow starts initially from the warehouse, like it is sent to the order is sent to the warehouse, so that the people find whatever the object we order for. After once it is concluded, okay, so that is what the object, the model number and all, then it is sent to uh, your next people, next team, that will be wrapped properly. And after once it is wrapped properly, it is sent to another team, so that they paste the address home to be couriered. Then it is sent to the courier department, and after once it is delivered to the person who ordered it, then it marked saying the work is completed, this workflow job sheet is completed. That's how workflows framed. So this is all about our course. We have multiple layers here in this AWS course. We have different levels. Now what we are discussing here, what and all the services I have listed so far, are part of AWS Associate Architect level course. Okay, Associate Architect level course, we are learning this, and it is all in terms of, when we speak about these three, it is all about infrastructure as a service. So being a cloud engineer, we should be able to know how to build an infrastructure. So if you know all these services, whichever we have listed so far, you will be able to create an infrastructure in the cloud. Fine. This is all about our course, all about whatever I wanted to discuss. This is all about the demo. If you have anything, any doubts, anything you wanted to clarify, I'm open to you guys now. Anything you wanted to clarify, you can ask me, so that I'll clear it. Is there anything?
Hello.
Yeah.
Yeah, this is Divya here. I
Yeah.
wanted to ask you, like, are you going to teach all the configuration from the starting, that how this should be configured in the system, or you will just like start teaching from that EC2 itself?
Everything. So whatever the services I have listed so far, everything will be discussed in detail with every single parameter, how to build it, how to utilize it. So everything will be
Okay.
discussed in detail without having any
And
issue from the scratch.
okay, got it. And just to be on the safe side, and like since I don't know much about this AWS, but when we talk about the job market, how much experience does like the employer wants that candidate should have? Uh, that's what I wanted to ask. Like, does that require like any kind of 7 years or 8 years of experience?
No, 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 nothing like that. See, there are very few resources available in the market, especially about cloud resources, cloud engineers, because cloud technology is coming up very much into the market these days. These days it is being popular. So it's not that you have to have a lot of experience, but even if you have a couple of months experience or 1 year of experience, it's more than enough. You have opportunities for the people who have the idea about cloud also. The only thing is you should have a corporate experience, okay, that you might have you would have worked on some technology earlier prior to this. Then even if you
Mm-hmm.
have a basic idea about cloud, you have opportunity. They'll say the total corporate experience and the relevant experience. So you can say relevant
Okay.
experience. I have couple of months experience, or I am aware of cloud technology. Then fine, you are having opportunities.
And will we get this software to practice?
But
Will we get this thing to practice?
I'm not clear. I don't know why your voice is not clear to me.
Hello, can you hear me now?
Fine, yeah.
Um, will we get this software or online access to practice this thing?
You're talking about access.
Yes, yes.
Oh, it's like a lab you wanted to perform, or what? No, it's not like you get the software to practice, Divya. It is just like you need to create an account. We have an option of creating free tier account for 1 year that is valid for 1 year. Okay, so with that 1 year free tier account, we can practice everything. The only thing what you need to have is to create an account in AWS. You should have an email ID and a debit or credit card for you. So that debit or credit card initially in terms of Indian currency they'll charge you 2 rupees. In terms of US currency they'll charge you $1, and that will be reverted back to you in a matter of 7 days only to check whether that debit or credit card is valid or not. And once you create your free-tier account that is valid for 1 year, I will instruct you what way that free-tier account is to be utilized so that you can play safe and then become hands-on without paying any single buy. Anything? Anybody else? Anything to be clarified? Yes. Fine. Looks like uh, all are okay. Having no issues. If that's the case, I'm going to end up this session. Yes. Fine. Thank you. Thanks for attending the session.
Yeah, okay.
Have a good day. Hope I could make some sense and then got what I mean,
Yeah.
like got what you wanted to understand. Fine then. Bye bye.
Yeah, thank you.
Thank you.